Hey everyone, and welcome. I think we got all the screens and windows and orders. I think we got the small banners removed as well. Well, thanks for joining in today. This is a little bit of a crunch time live stream. We are a very busy team these weeks. I have a lot of colleagues who are currently attending Civo Navigate in Berlin, and a lot of other stuff happening around. So for today's version of our live stream, you basically have to do with just me. Well, put my name out there. My name is Mikkel Mørkheim. I'm head of product Fermyon. And for those who seen some of these before, you've probably seen me here. So we've been thinking about a new concept for our live streams, and it works super well. I think if there's more than one person here, but again today it's just me. But the concept is basically show me your latest PR. So basically, whoever is willing to join one of our live streams, and I'll invite any one of you to sign up. Let us know on Discord if you're interested. You can become the guest and you will be asked the question, show me your latest PR. And basically the conversation would take us wherever that takes us based on what you went through in terms of crafting that pull request. Why did you create it? What's the next step? And I believe there's a ton of things to unpack by doing that. And I think we'll have some fun conversations when we try this out. So hopefully we get a chance to try that out soon. I think today I will, well, it's kind of cheating because first of all, I'm going to ask myself the question and then I'm going to have a conversation with myself. So feel free to chime in the chat as well if you think I'm not asking myself hard enough questions. But also I'm cheating in a different sense that I actually didn't create the PR yet. But I'll show you some of the stuff that the intention behind the PR is, and then I will promise myself to follow up with that PR very, very soon. Anyways, let's get started. So you can probably see that I put up our Fermyon workshop repo. So this is a repository that we created quite a while back. I actually don't know if there's a way where you can see when these things were created. Well, you can probably look at the history and then go all the way back. There's a lot of commits in here. Anyway, so does anyone know how to find the first commit and just sort of get an idea of the timeline of the repo? Let me know in chat. But this repository we have over the last years, I guess, few years, we've created these various workshops that are put out here in a way where you can sort of self-pace through them if you wanted to. Or sometimes we use these as we go out and conduct workshops at conferences and other places. And anyone is welcome to go ahead and do that if they want. There are basically two workshops in here. Yes, and we may have some of those keycaps left actually that we promised a while back. I at least have one on my keyboard. I know it's quite cute. But there are two workshops in here. There's a Magic-8-ball workshop that gives you an introduction to Spin, some of Spin's feature, Fermyon Cloud features, and then particularly uses serverless AI or LLM to create an application that uses Magic-8-ball. There's another workshop in here that is really focused on WebAssembly containers. You can actually combine the two if you want to. I think what we're going to do today is a little bit of combining the two because I just happen to have spent a lot of time today in a workshop talking about Magic-8-ball and also having it up and running inside of Kubernetes. And basically, that's what I'm going to walk through today. And part of that is going to be some changes to the TypeScript portion of the workshop because of our new TypeScript SDK, and also how we can get that application running in Kubernetes using Redis as a backend for KV store that's implemented, and offloading the GPU work, the actual inferencing from our Kubernetes cluster into Fermyon Cloud, so that we, we use the compute wherever the most efficient compute is available, because I happen to not have a GPU that I can use well on my machine and not even know how to make it work if I run a local Kubernetes cluster. So let's look at this. So the Magic-8-ball experience, really, we're going to build this application that has a front end that shows a Magic-8-ball. So Magic-8-ball, one of these that you shake, you ask a question, you shake it, it comes back with an answer. So typically it's like something, should I do something? And then the Magic-8-ball will say, absolutely. Or it can come back and say, nah, maybe tomorrow, try again, or something like that. So it can help you make up your mind if you want to. What we do in this application is we actually hook it up with the large language model, the Llama 2 chat models, create a prompt, and then we go and ask the prompt to the large language model, to craft the reply for us. So that's basically what it is. We will implement caching with key value stores, and finally we'll get this all up and running inside of a Kubernetes cluster. So let's go over here, and I have sort of cheated a little bit because I did update the TypeScript code for using our new SDK. And so this is the pull request I will create. I haven't created it yet, but the pull request that I will create is getting the sample code for this workshop for TypeScript updated to new SDK and extending it with the Kubernetes deployment. So to briefly walk through this code, it is pretty straightforward. So we actually have two things inside of our Spin application. We have the Magic-8-ball route with the Magic-8-ball component. That's the one that I'm building here. We know from the npm build that this is a TypeScript thingy, and we're using both a key value store, and we're also granting it access to the AI model Llama 2 chat, which is what this backend API is using. Then we're using the static file server version 3 to serve the content for our front end. So we have a small static site that we use as a front end for this as well. So those are the two WebAssembly components that are part of this. All of the static app is basically just some HTML and CSS and some icons that we have in the assets folder. But if we look at this, the backend implementation, the API that we use from the Magic-8-ball, this is what this looked like. There's one thing you would notice here. I think I don't remember, maybe last week, I think Karthik and Thorsten did a stream on the new JavaScript SDK. So you can definitely get some more detailed information about that over there. I think one of the things to note here is that there's some new stuff around nitwit and other things that we use in terms of how we actually create these WebAssembly from JavaScript. So we're talking about the Spin SDK 2.20 here. I guess 2.0 was the first instantiation of this, but this is now 2.0. Okay, so what do we do? So first of all, the function handler is dramatically simplified, I would say. So basically, we have this response builder that we can just directly use. So we can set status codes, append headers, and send back body content. And basically, a body content can be strings. Used to be byte arrays that we have to then encode and decode back and forth before sending them back. I think in the other SDKs we're still doing that, and I personally like the fact that I can just use strings to craft my response. In this case, we want to do a JSON object, so you can say we have this small answer interface that defines just like contains that one answer as a string, and then we do two things. So first of all, we want to check if whatever was asked for the Magic-8-ball, whether we have that question cached in our KV store so that we can save some GPU cycles and not have to go to the LLM again. So what we do is we actually take the text of the request that comes in, we log it to console so that we have a little bit of a record on it, and then we call this getter set answer function, passing on the text. and we expect to get an answer back. An object of this type implements this answer interface up here. The usual stuff we do around the KV, we open the KV, we see if we actually get the cache response back. So this get method, either it doesn't fail, but it will give us null if there is no key in there. So we have to check whether we got something back or not. There's also an exists method you can use. And to be honest, I did. So the thing is, even if we do exists, we will get a true or false, right? And so if that one is true and we do a get, basically there's no way to tell the compiler that because we did exist, I haven't found a way. Because we did exist and now doing get, we're sure the get will return something. So the exist method is sometimes a little bit, I haven't found a good way of using it actually. If anyone have, let us know, let me know. Maybe it's just the limitations of how I understand this. So I'm just doing get directly. And basically get is going to pass, by the way, I could actually have done this as a JSON. JSON value, but if I do that, I think, what is this going to give us back? This is going to give us back any. The question is if this is actually going to be a string. I don't know. We could test that out at a later point in time. Anyways, for now this works. So we're going to go and look, use the question just as the key. If it's null, meaning there is nothing in the cache, right? So basically we're going to set the answer, pass that on to the actual answer function down here. I guess that function should probably have a different name. Whoops, I'm not going to rename that one. Let's just not, instead of calling this answer, we should probably call this ask LLM. So we will then go and ask the LLM. Yeah, anyways, naming is hard, but whatever. If you have opinions, feel free to comment once the PR gets in there. But we're going to ask the LLM. And so down here, we're going to ask the LLM. We're going to expect an answer to come back. We're still just passing on the original string we got. And we will construct the prompt, put in the question. We will call the inferencing model, pass the response directly, the text response directly into the answer. This could probably be, there's probably some error handling in here that would be good to implement as well. Setting some properties, because of the Magic-8-ball, we want to have it fairly restricted in terms of how the potential for LLM hallucination, which I guess is the phrase that I've heard people use when LLMs sort of go off on a path, and yeah. So we're going to get a response back. There's a little bit of cleaning because the LLM, we asked them to prefix it with answer so that we can have some structure in the reply coming back, and because then we know from the response when to pick the actual answer. So we're gonna try and do that here. This is not going to be perfect, but it's fine for what we want to do. It shows the pattern of you can instruct the LLM through a particular prompt way of saying this is how we want to get this back. And then you can try and clean it up afterwards. I know there are LLM models being worked on that actually understand providing things as in some kind of data structure. I guess we could probably have asked this to give us a JSON object or something like that, but let's not do that right now. Okay, so once we have that back, we just return the response, and the response is now an answer. And we can cache that in our key value store and pass it all the way back up here, where this now becomes the response, which we then reply back. So that's the have not cached path. There's another path in here, which is yes, this is path. So meaning cache response is not null. I'm not even sure if this null checking is actually okay. I think it is, because get is either null or not. Yeah. Anyways, so in this case, we're basically now we need to decode because the store returns a byte array. So we're going to decode that cached response, pass it into the answer type, and then return that. And now that's what's going to come back. So this code is just really updated to the new JavaScript SDK. And if you wanted to see what the old looked like, you will go over here and we could take a look. And there is, I mean, don't know how much of simplification there is over this, but there is some simplification at least. You can see we had to encode the body previously, and I think even some of the, you know, this wasn't really using types as well. So, anyways, I hope this make this a bit more idiomatic TypeScript, and also we got the SDK updated. Okay, so that's what I want to do with this PR. Let's just make sure that this thing actually works. So let's create a new terminal, then let's build this thing. And so when I'm using the LLMs, and if you've seen some of our live streams before or looked at some of the AI stuff, Spin has a way that it can actually use a locally stored model, but it takes a long time running this on your laptop. What I can do instead is I can use a Spin plugin called Cloud GPU. So what this does is it installs a small application in Fermyon Cloud that is backed by real GPUs, and you have some free quota to actually do that. And now what I can do is I can pass in a runtime configuration when I'm running my application, so that whenever inside of my code I am using, you know, either infer or generate embeddings, that particular call will be routed by the Spin host up to Fermyon Cloud, and using those GPUs to get things back, and it goes much faster. So when I want to run this, I can do spin up, pass in that runtime config file. So my Cloud GPU is this .toml file. It includes an auth key in there, so I'm just not going to show it right now. But basically, when you run the plugin, Spin plugin, I think it's Spin Cloud GPU init, all of that will be set up for you, and the auth key and toml file will be provided. Okay, let's do that. And I'm using the default store. And someone is already on port 3000. I have no idea who that is, so probably should restart my machine after this. But anyways, I'm using a default store, which means that my key value store, and you can see, is just in the SQLite database file. And because I'm using the remote HTTP through the runtime config, my GPU queries are going to go to remote Fermyon Cloud. Okay, so here it is, the Magic-8-ball. We can ask it a question. Should I go ahead with this PR? Spin the ball, spinning. Yes, proceed with confidence. Thank you, 8-ball. That was a nice pat on the back. I will proceed with confidence. Okay, so basically what happened now, we ran this thing locally, the Spin application locally. The actual inferencing request was passed up to the cloud, and we got a reply back. What we can also see is that if we ask the same question again, we get immediately the same response. And this is because we are picking that up from our KV store. And if we wanted to check that, we can use the SQLite command tool and just dump what's in the key value database. And you can see, I've actually asked the Magic-8-ball a few other questions throughout the day. But you can see that basically we have that key in there, and then we have some representation of bytes, which is the answer, which shows us how all this is cached. So that's great. Now, if we wanted to deploy this into Kubernetes, there's a few things we need to do. First of all, we need to get SpinKube up and running. I have a cluster where I already have deployed SpinKube 2. And for those of you not aware, spinkube.dev is the place to go. And spinkube.dev is basically a a few projects that, well, it's one project, but together it enables you to run Spin applications in what you will consider a Kubernetes native way, which means that there's a particular resource type inside of Kubernetes, which is called a Spin app. It uses a container dshim to run these as WebAssembly using the Spin runtime directly, so not wrapped in a container or anything. So there's this whole way of getting Spin into Kubernetes where we package them as OCI artifacts and then pulls them in through the Kubernetes workflow. So the few things we need, well, actually, let's just quickly look at the doc. So a quick start, and which is what I've been doing so far, what I've been prepped for this stream is, I have K3D running locally, so I created a K3D cluster. There's a cert manager prerequisites we need. Then we need to deploy some runtime classes, custom resource definitions. We have an operator that ensures that when Spin apps are deployed or when Spin app definitions or resources are created inside of the cluster, that deployments and pods and so on are being created. And then finally, we create a shim executor. And the shim executor is a namespace scoped executor where we can also apply some configuration that will be used across our applications. And this is actually one of the examples that I want to show here. And basically what we end up then is are able to deploy our Spin applications using this new Spin app type. Okay, so let's take a look at what we actually have in. So I have the cluster up and running already. So we're not going to go through the whole deployment as much as we're just going to look at what's already in here. So the thing that I wanted to show to begin with is that I have my Spin app executor. And if we take a look at the YAML in here, it's going to be somewhat more complicated than what we will actually provide. But you can see I have a name for this. I have it applied to a particular namespace. So in the default namespace, I have a container dshim spin that I can reference from my Spin apps as I deploy them. And then what I also do is I have actually provided an OTLP endpoint, so an endpoint to have telemetry and metrics. So I am passing these on to the simplest collector default. I like that name. It's the name I picked up. Well, it's the Jaeger project who has this as part of the quick start in terms of how you can use an all-in-one Jaeger to actually do all of this. So that's pretty cute. But because I have this defined at the Spin app executor level now, any Spin app that I would deploy into my Kubernetes cluster, referencing this Spin app executor, will pick up that that configuration, and you can see traces and metrics being passed onto that collector. Whoops, I didn't mean to do that. So let's go back in here. I think the other thing that I then wanted to show is that I have a Jaeger instance, which is the one that I'm using. So this is the simplest collector one. So that's the one that we are passing on all our telemetry to. And I guess we can see that as a service, actually. So the simplest collector, that's the one. Then we have a query endpoint. This is where we want to go and see our queries. And the other thing I've done is I've also deployed Redis. So basically, I'm going to use Redis for my key value store. And then finally, I deployed my application. In this case, it's called DevOps Days. I actually do have let me check where the deployments, the deployment's over here. Yeah. Okay. And the final thing is that I also have a secret that, and the secret is equivalent to, what's in the Cloud GPU TOML file. So basically, it has the authentication key to talk to the Cloud GPU proxy, whatever we want to call it, that runs in Fermyon Cloud. So what this means is I can deploy an application looking something like this. So this is my Spin app. It is an OCI image, and I created that by doing spin registry push. So basically in my directory where I have my spin .toml file, I can push this all into a spin registry. And I'm pointing to the executor that I showed before that had my telemetry stuff configured. I'm creating 2 replicas. And then I pass in my runtime configuration. So the same way that I would use a runtime configuration here, to both point to the Cloud GPU, but could also actually point to Redis for the key value store. I'm doing the same here. So I'm saying my key value store is going to be backed by Redis. This actually should be default, unless I called it Redis somewhere else. This is a good question. Let's see. What do we call it? We called it default. So yeah, this one should be default. So this is of type Redis. So the default key value store here, that maps back into spin.toml, where this component asks for key value store called Redis. And then I'm pointing to Redis. So if we go over here, we should be able to see that we have a service in here, which is Redis. That's this one, backed by a Redis, single Redis container. And then I have this LLM compute configuration. So I'm using remote HTTP. This is the URL that was given to me by the GPU. And then my auth token is called LLM Fermyon Cloud and is in a secret called LLM Fermyon Cloud, where we will get the auth token to talk to that GPU endpoint. And then I also have our Redis deployment in here. So this one will also be part, I need to do something about the image, that will also be part of my PR. So I can go and deploy all of that into my Kubernetes cluster. And I think the thing that I want to just show now is we can set up a few port forwards here. So let's do the query thingy. So this is our Jaeger instance, and we also want to do this. So this is our application, and I think that's it. So let's go over here in a browser, and we can do localhost. So that will be our Jaeger instance. We can just check the last 5 minutes. Nothing happened. Let's set up another one where we want to get our application. So that will be 8080. So this is the application now served from the from a Kubernetes cluster. We could, for the sake of it, we should be able to see our logs. Should I do a live stream is what I asked. Maybe, but plan carefully. So I did plan carefully for this one. Okay, what are we going to ask the Magic-8-ball now? We did ask about the PI. It said, proceed with confidence. Should I ask my CTO to code review the PR? That's a good idea. Yeah, I think that's a good idea. Okay, Radu, there will be an incoming PR to review for you. But you can see we actually have the log showing up from the pod or from the spin-up that we deployed. And what we should also be able to see is, traces. So there you go. There's something that we need to figure out because I don't think I get all the traces that I expected to see, but I know Caleb will be able to let me know why and potentially figure out what I need to fix or what someone else needs to fix somewhere. But at least some stuff we saw. We saw that we got the store. It took 6 milliseconds to get the store. We were getting the value in here. I am actually interested in figuring out whether this one went off into our, no, this is still using SQLite. Okay, this one should have used, I didn't redeploy the thing that I changed. Okay, anyways. But the thing that we definitely want to see is that we see the inferencing call that we did down here is 7 milliseconds almost. So that was an inferencing call that went off because we were not using the cache. Now, if we ask the same question again, you can say we get an answer back. By the way, I did fix the double. This is fixed in the code that I showed you. I just haven't redeployed. But what I want to go back and see now, so this get store down here was a 1.26 second, and we should be able to see that this one, now we have the post and everything. But anyways, we're down to 14 milliseconds now. And the big one is really that we don't see that there is a, if we want to compare these two traces, I think we can pick up the trace ID somewhere here. Now I am on depth. Oh, is that the one? 46C. That might be the one. Oh, haha, I think we can do this. Okay, that was much easier. Yeah, there's not everything is going to be picked up here, but at least just looking from the duration, 14 milliseconds versus 1.26. So definitely worth using a cache. And I know that we did cheat a little bit because this was actually a local file cache within the pod and not the real one. You know what? Let's just go and apply this update. So we should get this running off of Redis. Let's just check this. So the deployment DevOps day, has this changed? Did the configuration change? What is the YAML sale? Oh. So, I probably need to go and check out the Spin app to be able to see this. Yes, that's the one. Okay, so now we have the key value store default set to point to Redis. Okay, let me go back and see if that works. So I would expect this one to now not be able to find this in the cache. So it's still picking up the old cache. Interesting if that change did not make it restart. It doesn't look like. Huh, okay, that might be a thing we should look into. Let's do this. Let's go and actually let's do something else. Let's go over here and then we can do k delete. Let's get rid of everything. Set these things terminating. Gone, gone, gone. Let's go and apply again. So Redis is creating, Redis is running. Bop, bop, bop. I am waiting for the parts behind the Spin app to show up. Okay. So I have the Spin app. Deployment not found. Deployment not found. Yes, I agree. Deployment not found. Still waiting for that deployment to show up. What is the controller? Oh, failed to reconcile deployment. Spin app. Core spin operator. Controller guide. What's going on here? Spin app namespace default. Oh, that's not namespace. Oh, come on. Can we? I want to see if I can get a bit more real estate on this one. I can't. Anyways, let me get back here. Okay, so that one failed. Let's go to the Spin app. And then let's just delete this one. That's interesting. Well, let's go back and just try and redeploy this. So we should be able to have the Spin app being created. Okay. Should we be hard on the operator and just restart it? Let's see what happens. Okay, there's definitely something going on there. Let's do lock, and then let's do oops. What is it? Is it get? No. kubectl logs. Okay, I want to get the I want to get the pod, not the Redis. I want to get into all namespaces. What is the namespace? Is going to be spin operator, and then I want to have the yes. Okay, so fade to stop. Oh, runtime prefix secret key not found. Okay, so something wrong with the key. That was nice. Secret key ref. Huh, is the secret not there? Let me just go and apply the key again. Oh, the secret. That one is unchanged. I'm just going to move the thing over here. I'm not going to share my. So give me just a second. That's the name. That's the data. What is this supposed to look like? Let's look at the API. Well, actually, let's look at the key value store sample. So secret ref name kb secret key. So I have secret key ref. I have key and name. Well, anyways, I changed them around. Whatever. Ooh, I think I might know what. So let me just check how this one from little. Okay, I'm gonna do this to create my secret. Just hold on a second. And we will call this LLM Fermyon. Will soon be there. Oh. Okay. Now. Okay. I should have updated that one. And let's see if I got this right. Okay, let's go back. Let's get that one again. Okay, It is for some reason not able to find the secret. Well, all I can say is this used to work, and I'm not sure why that secret key ref is not how I wanted it to be. I'll check one last thing, and then we'll move on for this. So I have that. Oh, you know what? Maybe I have switched the name and the key around. Let me try one last thing. I know it's super cool live streams where you actually do what you do behind the scenes, but okay, I think I got this right. I think basically what I did is I had confused myself with name and key, so I have those switched around. Okay, let's go and take a look at our spin app. Okay, they're now up and running. Okay, so back to where we were. We wanted to. Okay, should I ask my CTO? Let's just refresh. Okay, I don't have my port forward set up. We can fix that. Let's go to our services and then this one, and let's create a port forward 8080, and then we also wanted this one on 16686. Okay, so we have those. Try again. Okay, should spinning. Definitely, it's a good idea. Okay, so that's interesting. That was the same response we got the last time, but this was not supposed to be cached. And also, I'm pretty sure this wasn't. This is the request we did. We did remote inferencing. We can see that. Let's go back, ask again. Okay, that one came back pretty quick. Let's see what's going on. Okay, and we're doing some Redis stuff in here. So if we probably, let me just check. Let's just compare these two. Okay, those were not comparable. But anyways, I want to see the last one here. So we got this from the store. We are at 767 microseconds. So I assume this actually used Redis now, but we could just check that out if we went to our Redis pod. And what do we want to do? We want to run a shell. And then we can do something like Redis CLI, I believe. And then we can do keys. Let's check. Yes. Okay. So we can see we actually have that key cached in that Redis key value store now. So really, point I wanted to get to is in terms of the PR that we can take this Magic-8-ball workshop that we've done, and we can actually package it up so that we have our key value store cache in Kubernetes, backed by Redis or some other key value store implementation that we support. And then also offloading the GPU into Fermyon Cloud so we don't have to rely on GPUs in our own cluster, but can actually use a hosted GPU in that sense. And we can sort of see how all that works together. So that's what I wanted to show. Thanks to anyone who stuck around for this. I hope you enjoy this, and be back next week, and we'll see if we can find some other interesting PRs to look at or things that are coming up. And I hope you have a great rest of the day. Thank you.